In this class, we will discuss about question number 15, exercise 9.1, some applications of trigonometry. So what about this question? This is the last question of this exercise. So observe carefully. A straight highway leads to the foot of a tower. What? We are having one straight highway, and this straight highway leads to the foot of a tower. This is tower. CD is what? Tower, and foot of this tower is this one. So this straight highway is leading towards the foot of a tower. Clear? It is given in the question. A man standing at the top of the tower. A man is standing at, this is the tower, its foot is this one, and its tower, its top is the top of this tower is this point. So a man, what? A man standing at the top of the tower and observes a car at an angle of depression. Man is there, and this man observing a car where? At the highway. Man is observing a car at an angle of depression. So man is there, and man is looking a car downward. So man lower the head, then we are getting angle of depression. So angle of depression will be the 30 degree, and car is there. So angle of depression, a car at an angle of depression of 30 degree which is approaching the foot of the tower. Observe again what is given in the question. We are having one straight highway, and this is leading towards the foot of the tower, and top of the tower is this point, and man is standing at this point and observing a car on a highway. So angle of depression of this man is what? 30 degree, and that time car is what? There. Once man observing this point, this car, then angle of depression is what? 30 degree. Car is going with the uniform speed. After 6 seconds later, what? 6 seconds later, after 6 seconds, car is reached from this point to this point. Clear? What? 6 seconds later, the angle of depression of the car is found to be 60 degree. First, man is standing at the top of the tower and observing a car, and car is at the point of A, and angle of depression of this car is what? 30 degree. 6 seconds later, after 6 seconds, car is moving towards the foot of the tower, and after 6 seconds, car is reached this point, and that time angle of depression from this point is what? 60 degree. From this point, angle of depression is what? 60 degree. Clear? Find the time taken by the car to reach the foot of the tower from this point. Now we want to find the time taken of a car to reach at the foot of the tower from this point. Now car is at this point, so from this point to reach that point, what will be the time required? We want to find this one. So how we will solve? First, we are assuming height of the tower is h meter. What? The height of the tower, we assumed CD equal to h meter. We are assuming base BC. This distance, we require the time for this distance to travel. Clear? We require this one. So we are assuming distance is x meter, BC is x meter, and this distance is a y meter, AB is a y meter. Now we are having horizontal line. Observe, assume this is a horizontal line, and angle of depression from this point is 30 degree. If this is parallel to this one, then we are getting this angle will be equal to this one. Why? Because both are alternate interior angles. And if we are having 60 degree angle of depression, then this angle will be equal to this one. Why? Because both this angle and this angle are what? Again two straight lines we are having, two parallel lines we are having, one transversal is there, then we are getting alternate interior angles and they will be what? Equals. Alternate interior angles are what? Equal. So what we can say, angle ODA, this angle 30 degree angle will be equal to DAC 30 degree. Why? Because alternate interior angle. And ODB, it means this angle 60 degree angle will be equal to DBC equal to 60. Why? Because alternate interior angles. Clear? Now we want to find time taken by the car to reach from the foot of the tower from this point to what time required to reach this point. We want to find time, we want to find. So how we will find? We are having two right triangles. One is this one is acute angle 60 degree, another one is this angle, this triangle, and for this triangle acute angle is 30 degree. So both right triangles we will use. First I am using in right angle triangle BCD. We are having acute angle 60 degree, its opposite side will be the perpendicular and its adjacent side will be what? Base. So we are having perpendicular and base, so we will use tangent theta. So theta will be what? 60 degree. Now then what we will be do? We will put the values. Tangent 60 degree will be what? Square root of 3, and CD we assumed is the height of the tower and it is equal to what? H, and BC is what? X we assumed. So once we solve, cross multiply, then what we are getting? Height of the tower will be the x square root of 3 times of x. I am putting as equation number 1. Clear? Both are unknown, x and h, height and this distance we are not having, so we will consider as it is. Now next triangle. Now in right triangle ACD, for this right triangle we are having acute angle 30 degree, so its opposite side will be the perpendicular and its adjacent side will be what? Base. So in right triangle ACD, right angle triangle ACD, we are having acute angle, we are having perpendicular and base, so we will use tangent theta and theta will be what? 30 degree. Now put the values. Tangent 30 will be 1 upon square root of 3. CD is the perpendicular and it is assumed as H, and AC is what? Sum of both this and this, or we assumed as x plus y. This can be written as x plus y will be what? X plus y will be what? H times of square root of 3, and I am putting as equation number 2. Clear? Observe. We are having h equal to square root of 3x, and in the equation number 2 we are having x plus y equal to h square root of 3. Clear? Once we use both equation, we will put value of this one in this equation. Then what we are getting? Put value of h, put value of h from equation 1 to 2. Then what we are getting? Put value of this from equation 1 to 2. Then what we are getting? X plus y will be what? X plus y will be what? H what? Square root of 3 into x into square root of 3. Solve this one. This can be written as what? X plus y will be equal to square root of 3 into square root of 3 will be what? 3x. Clear? And this will be what? Equation number. This will be what? Equation number 3. Observe what we are doing. First we are using this right triangle and we are getting this relation. Then we are using this right triangle and we are getting this relation. By using both equation, once we put this value in this equation, then we are getting this equation. We want to find what? time required to reach from this point to this one. Clear? So we are having what time, what this point to this point we are moving in 6 seconds. Time, what will be the time in between? Car is taking 6 seconds, not 6 minutes, 6 seconds. Car is taking 6 seconds. So we are assuming speed will be what? K kilometer per second. Then time will be what? Distance upon speed. Time is what? 6 seconds. And distance is in between both. We are assumed as a y. And k is what? Speed we assumed. Then this will be what? Y equal to 6k. This will be what? Equation number 4. Clear? Now put y equal to 6k. Put y equal to 6k in equation number 3. Then what we are getting? Put y equal to 6k in equation 3. In equation 3 we are having equation number 3 is what? This one, x plus y equal to 3x, in which we want to put this value. Then what we are getting? X plus y equal to 6k equal to 3x. Solve this one. 6k will be equal to what? 6k will be equal to 3x minus x. 6k will be what? This will be what? 2x. This will be what? 2x. So what we can say? X will be equal to 3k. Yes or no? Once we divide this one by 2, then we are getting 3k. So x is what? Distance. Distance between this point to this point is what? X. Distance is what? X meter. So what we can say? Distance equal to time into speed. Time into speed. Distance equal to what? Time into speed. So we required time. Speed is what? K. We assumed speed is what? K kilometer per second, and time is what? 3 seconds. So time to reach from B to C will be what? Time equal to 3 seconds, and this will be what? Required answer. Observe what we are doing in this question. We are having one car, and car is moving towards the foot of the tower with uniform speed. First, once we observe from the top of the tower, angle of depression is 30 degree. After 6 seconds, car is reached to this point, and we want to find time taken to reach from this point to this one. So first we will consider this right triangle, then we will consider this right triangle. We are getting two equations. Once we put this value there, then we are getting this equation. We require time from this point to this point. We are having time what? 6 seconds. We assumed distance is y and speed we assumed is k kilometer per second. Then we are getting one relation, this one. Then we will put this value in the equation number 3, then we are getting what? X equal to 3k, and x is what? Distance. 3 is what? Time. Distance equal to time into speed. From this formula we can say distance will be the time into speed. So 3k is what? Time into speed. Speed is we assumed as a k, so k is the speed, but 3 will be what? Time. So what we can say? We are required to reach from this point to this one. Time taken by the car to reach the foot of the tower from this point we are having so time required to traveling from this point to this one, we are having 3 seconds. From this point to this one, we are required 6 seconds, but this point to this one we require only 3 seconds. This is required answer. I hope you understand this question. That's all about this question. Thank you so much.